Now, the most common angles are shown here on this diagram, and I suggest that these are ones you just simply learn. You don't want to be working them out. It saves you a lot of time if you just know them. And you use them so often. So now we're going to move on and look at arc length and sector area. So arc length is part of the way around a circle. And a sector is like a slice of pizza, and we want to work out the area of sectors as well. And this circle has a radius of r, as we can see. Now, if we consider the length of the arc first, initially working in degrees, we know the circumference of a circle is 2 pi r. Now, the fraction of the way round this arc is theta divided by 360. Remember, 360 is all the way round, so we're doing theta out of 360 of the way round. So in degrees, that's just theta over 360. So that's the fraction of the entire circumference, 2 pi r. Now convert the angle into radians. So you multiply by the angle theta. If we want that angle instead to be in radians, so I'm multiplying by 180 over pi. Now we can see there's some cancelling here, like so, and then that 2 will go with that 2, and the pi on the bottom here with the pi there, and all we end up with is r theta. The formula is very much simpler when we're in radians because the radian is an intrinsic measure of a circle. The area of a sector, in the same way, well, I've actually called this angle phi here and it's called theta here, but don't worry about that. It's the same idea. It's the same fraction of the entire area, which is pi r squared. And if you do the same thing, multiply by 180 over pi, what you get is a half r squared theta. And I've put the circular measure there, c, just to, in this situation, distinguish it from the degrees. So again, very much simpler formula, half r squared theta. So let's look at example 5. A sector has a radius of 10 centimeters, so that's our value of r, and an angle of 2.5, so that's our theta. Find the arc length. Well, L is just going to be 10 times 2.5, just r times theta. Remember, L equals r theta. And we're going to do the area as well. That's a half r squared theta. So that's just going to be 25 centimeters. And the area is going to be a half multiplied by r squared multiplied by 2.5. So that's a half times 100 times 2.5. So that is 125 square centimeters.